Hello everyone, this is a question that was asking at 2025 mechanical engineering. So this is question number 63 and this was asked for 2 mark and belong to machining and machine tool operation subject. So it is saying cylindrical workpiece of diameter 60 mm and length 400 mm are machined on a lathe at a cutting speed of 25 and at a feed rate of 0.2 mm per revolution. The tailor life parameters C and N for this setup are 75 and 0.25 respectively. The tool changing time is 3 minutes. Okay. With the labor and overhead cost of Rs 5 per minute. Okay. The tool changing cost per piece is. So we have to find the tool changing cost per piece. So they have given that diameter, length, that cutting speed, feed rate, and tailor constant, tool changing time, and labor cost. Okay, you can find more concept related to this question by using this reference link. Okay, now let's solve the problem. So they have given that parameter, diameter, length, and other parameter also. They also given that feed rate and tool changing cost, minute, and labor labor cost also. So we know that we know Taylor's equation. So B, what is B? B is that velocity, and T is our tool life. C is the constant. So by using this equation we can find T. So by putting in this equation, so we have given that we are having T equal to 25. Okay, we have given that B equal to 25. T we have to find, and N we are having N 0.25, and C we are having 75. So we will get tool life. We will get tool life T will be equal to 81 minute. Okay, so this will be our tool life. Okay, we also know that relationship between cutting speed with number of revolution given by this expression. So N equal to 1000 into B by pi d. Okay, so now let's find the machining time. Okay, so what will be machining time? Machining time Tm will be L by Fn. Okay, so we are having L length 400 mm and our F they have given feed rate. So now let's putting all the parameter in this equation. So we will get Tm equal to machining time equal to L, we are having 400. Okay, feed rate we are having 0.2, so we will get 0.2. Okay, then we are having N, and we know this one. So N we are having 1000. Into velocity we are having how much? 25 meter per minute. So 25, then divide by pi, into diameter we are having 60. Okay, so what we will get? We will get from here Tm equal to machining time will be our around 15.0857 minute. Okay, so this will be our machining time. So we know that our tool life and we know that our machining time. So what we can find that we can find that number of tool failure per piece. So this will be our Tm by T. Okay, so this will become Tm we are having 15.0857 divided by we are having tool life 81. So we will get this one around 0.1862. Okay, this will be our that number of tool failure per piece. So Tm by T, this will be our 0.1862. 1862. Okay, so what we can say that like tool change cost per piece. So what will be our tool change cost per piece? This will be our like labor cost. So this will be our labor cost into it will be our number of tools. So I will like this one, number of tool failure into tool changing cost. So by multiplying all these three, we will get our total, like we will get tool change cost per piece. So this will be our, like this labor cost we are having how much, 5 into this one we got number of tool failure per piece, we got 0.812 0.1862 into like tool changing per cost they have given 3 minutes. So we are having this one 3. So how much we will get? We will get this one around 2.7936 RS. Okay, so this will be our tool change cost per piece. Okay, so what we can say that our tool changing cost per piece, this will be around 2.7936. Okay, so this will be our answer. Thank you.